What we're doing in 2.5 is kind of an introduction to proofs. Have you heard of proofs before? Proofs is a big part of geometry in that you're proving when something is true or false, okay? So we're going to have to learn how to prove that things are true or false. So today, we're not really doing a lot of proofs, but I am just going to show you kind of the basic setup for how a proof will often look, and we're going to walk through a little bit of that. To do proofs, you need to know properties. You need to know the rules or the properties or the theorems that apply to whatever it is we're trying to simplify. So a proof is really just like, here's what I know, here's what I'm trying to find out, how did I get there, and what are the reasons for how I got there, okay? So people oftentimes will freak out about proofs because they're like, I don't know what to do. All you have to do for a proof is solve the problem and tell me why, okay? So we're gonna start with just a few properties because you're gonna use these to prove what we need to prove. Very few of these should be new to you. Well, maybe about half of them, I guess, are probably new to you. The addition property, you guys use this one all the time. If I give you an equation that says x minus 6 equals 4, how do you solve that? You add 6 to both sides of the equation, right? So if I'm adding the same thing to both sides of the equation, that is the addition property, right? We added c and we added c to my a equals b, okay? That's the addition property. Same goes for subtraction. You subtract the same thing from both sides. That's subtraction property, okay? Multiplication property is if you multiply both sides of your equation by the same thing. So like if I have x over 2 equals 10, what do you do to solve for x? You multiply by 2, right? So if I multiply by 2 on this side and multiply by 2 on that side, that was the multiplication property, okay? You multiplied both sides by the same thing. And then division property, you divide both sides by the same thing. If I have 2a equals 20, if I divide by 2 and divide by 2, I will get my answer, okay? That's the division property. Those should not be new to you. You've done those for a long time, okay? The ones that might be new to you are these next 4. Actually, really just the next 3. So the first one is the reflexive property. Reflexive property seems like a really odd property because, for instance, it's A equals A. And people go, well, duh, I know that A is equal to A. But in geometry, what you're gonna see is sometimes you need to use that idea to get you to a new place, okay? So the reflexive property, you're gonna use a ton, even though it seems very simple, that something equals itself, okay? I always tell people, think of your reflection. If A looks in the mirror, what is he gonna see? A, right? So that's the reflexive property. A looks in the mirror, he sees A. Symmetric property says if A equals B, then B equals A. It's kind of like the commutative property where you're just switching the order, okay? You could draw a line of symmetry. It's like this, right? I have my hand here, I have my hand here. A line of symmetry would be if I fold on that line, they match up perfectly, right? It's just your letters are going to match up. So A equals B, when you flip it over, it's B equals A. Okay? The transitive property, tell me if you can give me something we've done in the last couple weeks that looks like this. If A equals B and B equals C, then A equals C. Does that look like anything we've done recently? What is it? The law of syllogism. That would be syllogism, right? So this looks a lot like the law of syllogism. You take out the two things that are the same, take out your B's, and you're left with A equals C, okay? So this one, you can just kind of think of it as the law of syllogism. Very similar to that idea. And then the last one is substitution. And basically what that says is if A is equal to B, then I can take out an A and put in a B, and nothing changes, right? So you're just substituting. If you're playing basketball and you take out a point guard, you want to put in another point guard, right? It's substitution. You're subbing players, you're subbing equal values, okay? Okay, so there's those properties, and then there's the distributive property. That's the one that just says if it's a number times two things in parentheses or more, you need to multiply that number by both those things. So this becomes A times B plus A times C. Same works with subtraction. It would be A times B minus A times C. Okay? Any questions on those properties? Okay, then what we're going to do is we are going to use this problem here to kind of talk through what exactly is going on here. You are looking for the steps, the reasons we know what we know, okay? So the question is, what is the value of x? And it says justify your steps. This is kind of what a proof will look like. We just want to know why for each of the things that you did, okay? So the first one says angle AOM, that would be this angle, right? Angle AOM, and angle MOC, that would be this angle, are supplementary. How do I know that those two angles are supplementary? The straight line, okay? We call that a linear pair. Because they are a linear pair, or you could say they form a straight line if you wanted to write it out a little more extensive. You with me back there? Yeah. So that would be a linear pair, okay? From that step, then they said, okay, well, if that's true, then the measure of angle AOM plus the measure of angle MOC has to equal 180, okay? Notice what they said right here. They told us those two are supplementary. So how do I know that the sum of them is 180? They are supplementary. That's just the definition of supplementary angles. And I'm totally fine if you shorthand that a bit. Definition of supplementary angles. Okay, so now you look, how did I get from step 2 to step 3? It was the measure of AOM. Now it's 2x plus 30. It was the measure of angle MOC. Now it's x. What did I do? I took something out and I put something in of equal value. Substitution. I took out the point guard and I put another point guard in, right? So that's substitution. Okay. How did I get from here to here then? To 2x plus 30 plus x. Now it's 3x plus 30. We didn't distribute it because we weren't multiplying by it. This one wasn't one of the properties we just talked about. If you just work on the one side and make it a nicer thing to work with, what do we call that? Simplify. We just simplified it, right? So you can just call that simplify, or if you want to, you could say combine like terms, but I'm fine with simplify. Okay, now how did I go from step 4 to step 5? What did I do on both sides? Subtraction, right? I subtracted 30 from the left, I subtracted 30 from the right. So that's the subtraction property. Okay, and then what's your last step? Division property. I just divided by 3 on both sides, so that's your division property. Okay, so this part of it you could probably do on your own. This part of it is just the why behind it. Why were we able to do that step? Here's why. Okay, so when they say justify, that's what they're looking for. Tell me why. Okay, questions on that? Okay, this list here, this next list, is the same properties, but in geometry terms. So when dealing with geometry, instead of saying A is equal to A, like a value is equal to a value, now they're gonna say a segment is congruent to a segment, or an angle is congruent to an angle, okay? These are the ones you're gonna use a bunch. Really reflexive and transitive come in proofs very often, okay? Symmetric, you don't see a whole lot, but you do see it every now and then. So those properties are nothing new. It's just like the properties of algebra, like those first ones that we talked about. Okay, the idea behind them is the same. Those are just with equality, more algebra-ish. These ones are congruence, which is going to be more geometry. Okay, so notice segment AB congruent to segment AB. That's the reflexive property. Symmetric property would say if AB is congruent to CD, then flip it around. CD is congruent to AB. Same goes for the angles. You can switch the angles, you can switch the segments, okay? And then transitive, this is like law of syllogism. And again, you can do it with the segments or you can do it with the angles. That would be your transitive property. So if angle A is congruent to angle B and angle B is congruent to angle C, then angle A is congruent to angle C. Anyone know which other property you could use in this setup? What could you say that property is? It's one of the ones we talked about. You could call it substitution, right? Because we're taking something out and we're putting something of equal value in. So substitution and transitive property are kind of interchangeable a lot of the time. So just know if I say substitution, you might be able to say transitive, or if I say transitive, you might be able to say substitution. Just kind of depends on the problem. Okay, so you're going to be doing some naming of properties. So look here. You start with this, 3x minus 1 equals 10. It becomes 3x equals 11. Can you tell me which property you used to get there? Addition, right? We just added 1 and added 1, so that would be the addition property. Okay. Look at B here. It says angle O is congruent to angle L, and angle W is congruent to angle L. So angle O is congruent to angle W. Which property would that be? That is the transitive. It's the syllogism one, right? But the name of the property is not syllogism. So don't tell me syllogism. Tell me it is the transitive property. Or you could call it what? Substitution, right? If I know that W is the same as L, then I can take out the L and put in the W, so it looks like that. So it could technically be substitution. All right, if the measure of angle E equals the measure of angle T, then the measure of angle T equals the measure of angle E. What's that one? That's symmetric. Any questions so far? Okay. Then, this is how your proofs are often going to look. Here's some statement, here's something I know, and then here's the reasons why we're able to do that step. So I'm just going to show you the basic format. Notice these are identical, right? I'm going to show you the basic format here just so you know like the rules to make sure of, and then we'll actually walk through the whole proof. But the first thing I want you to note is this. This number 1 spot, and this isn't always true in the book. Sometimes the book doesn't do this step. I want you to still do this step, okay? I will do this step on every single quiz or test you take. It is this. Whatever was given, okay, this information here, you're going to take the portion that was given. So you're going to take this, and you're going to put it here. So this would be the measure of angle 1 equals the measure of angle 3. And the reason for it is it was given to you. Okay, that will be the first step of every single one of your proofs. Even if the book doesn't do it that way. For me, you will always give me that first step as here's my given information. Because the whole reason they give you the given information is that's your jumping off point. That's your starting point. I have this. Okay, now where is that going to take me? Okay, so step 1 will always, always, always be your given. So this row is always whatever your given information is. Okay, the other thing is this bottom one, this number 5, for instance. I'll usually tell you how many steps the proof is made up of. A lot of times I even give you the whole left column, but if I don't give you the left column, this right here is always whatever they asked you to prove. Your very last step is always like, they're saying, prove this. Prove the measure of angle AEC is equal to the measure of angle DEB. That will always be your last step, right? Because that's what we're trying to tell them is true. That's what we're trying to prove. So here it is, and here's why, okay? So you will say the measure of angle AEC, sorry, that's really messy. I'm gonna get this guy out of here. So for that last step, it's the measure of angle AEC is equal to the measure of angle DEB. Okay, whatever they asked you to prove. And then the other thing to note is you will always have a picture to go along with it. Okay, that picture is your best friend. That picture is telling you things that you need to know to get to your final result. Okay, how are we doing? Questions? Okay, so let's take a look at this proof. Step 1 is always what? Given. The given. So we're going to say what they told us in the given, the measure of angle 1 equals the measure of angle 3 because it's been given to us. Okay? Now think about what they're asking you to prove. They're asking you to prove that AEC, which is my purple angle here, okay? They're asking you to prove that that angle is congruent to DEB, which is the blue angle, okay? We already know that 1 is congruent to 3 because it was given. What else is part of both of those angles? The bigger angles. What's identical about them? So if you look at the purple angle, right, this, if you look at the blue angle, this, what about them is exactly the same? Where is the overlap, in other words?
BEC.
Right, it's BEC, it's angle 2, okay? So here's where you're going to see that this comes into play. You're going to say for that step that the measure of angle 2 is equal to the measure of angle 2 because we're thinking of them as parts of two different angles, okay? Which property is that? Where we say that something is equal to itself. If I look in the mirror, that's the reflexive property, right? Think reflection. So that's the reflexive property, okay? Now from there, I'm going to say, and here's what you have to think about. I know 1 is equal to 3, and I know 2 is equal to 2. So I can say the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 2, right? If I add these two together, and I add these two together, because they are equal and equal, then the sums of them will also be equal. Do you know which property that is? I added the same thing to both sides of my equation. It's the addition property, right? I added angle 2 to both sides. So that's your addition property. Okay. Can you tell me the measure of angle 1 plus the measure of angle 2 in a different way? What is that angle? Angle 1 plus angle 2. Is there another way you could name it for me? Angle AEC. Okay, so what I'm going to do, step 4 actually has 2 parts, but it's the same reason, so we put it as the same step. So I'm going to say the measure of angle 1 plus the measure of angle 2 is the measure of angle AEC. And then the second part of it, 3 plus 2, the measure of angle 3 plus the measure of angle 2 is what angle? Sorry, you can't really see it on here. That would be BED, or the way they named it is DEB, so I'm just going to stick with that so I don't confuse you later. What did I just do there? So I told you in step 3 that these two things were equal, but in place of the 1, I put something of equal value in. That's substitution. Next one, substitution. This is actually angle addition postulate. Remember we said if this plus this equals the whole thing? That's your angle addition postulate. So we're just saying the sum of two angles equals the whole thing. Angle addition postulate. Excuse me. Then we're going to substitute. So I said 1 plus 2 equals this, 3 plus 2 equals this, and I know that those two equal each other. So I can say that these two things have to equal each other. The measure of angle AEC equals the measure of angle DEB, and that one is by substitution. Okay, so you just have to like slow it down and think, why was I able to do that? How was I able to get there? You won't do a ton of this yet. Like, you don't do a whole lot of this on quizzes and tests yet. But it's just kind of an introduction for you, just to get a feel for how are these proofs going to look. Chapter 4, they show up a lot. Chapter 3, there's a few. Chapter 4 is all proofs. It's just how am I getting from point A to point Z, okay? Any questions on that format? All right.